Okay, let's take a look at two more examples that deal with differentiability and continuity. So this is a piecewise function. We're going to go ahead and sketch this graph. So to the left of -1, we're going to sketch negative 3x minus 3. So I'm going to start at -1. So if I plug in -1, I am going to get 0. And then my slope is -3, so I'll go ahead and count it out. 1, 2, 3. So the graph looks something like this. And then the right side of the graph is a parabola. Vertex is at 1, 0. So again, I'm just going to make a rough sketch. So it looks something like this. So there's my graph. So the first question is the function continuous at x equals -1? So just from the picture, I can tell it's continuous. I can draw it without lifting my pencil, but let's go ahead and use the definition of continuity that we learned before. So remember, the definition of continuity says, first of all, there has to be a point there. So f of -1 is 0, all right, that's that point. Second condition is that the limit has to exist. So if I take the limit as I approach -1, the limit from the right hand and the left hand both approach 0. And since both of these are equal, which is the last condition, then yes, it is continuous. So therefore, it is continuous. So these are the same. Okay, the next question asks about now differentiability. So I want to know, is this differentiable at x equals -2, which is right here? Okay. So I can tell it is differentiable because there is a slope that exists there. That's all that means. But now we want to be able to explain it analytically. So remember we talked about we need to use the idea of using that limit definition. So when I take the limit, when I look at the derivative from the right side of the graph, right, this is your f of x minus f of c over x minus c, and we're using -2 as c. This is the same value as I approach -2 from the left side of the graph, right? This is just a straight line, so as I approach it from the left, as I approach it from the right, the slope is always -3. So it's because those two limits are the same that we can say that is differentiable. Okay, we're going to skip C, and we're going to look at one last one here. Okay, so this one's not a straight line. It's a piecewise. You've got a line as well as a curve. So the question is f differentiable at x equals 0? Again, when I look at just the picture, I can tell the answer is going to be no because we have a cusp here. But we want to use that definition of the derivative using the one-sided limits to justify my answer. So let's look at our limits. So if I look at, as I approach 0 from the left side, okay, as I approach from the left side, it is a straight line, so I can figure out the slope of this line exactly is 2/3. Okay, let's go ahead and do the right side limit derivative. So as I approach 0 from the right side, notice that the slope is always positive. I'm sorry, the slope is always negative. So this is a number less than 0. So it doesn't matter actually that this was 2/3, we just knew it was positive. And we're not going to be able to find the exact value of this, but I can tell as I approach that graph, it's always negative, so these are not the same. That's why it is not differentiable at x equals 0.